3. So problem number 3 is using the corollaries from theorem 62. So the corollaries come from that theorem, and here's the first one. It's a little bit easier. If I want to find the altitude, now again, the altitude is taking that right angle of the big triangle and that segment cutting that, right? So there's the altitude CD. So if I want to find that, I just find the geometric mean between AB here. So that'd be the short leg of the small triangle. And the long leg of medium triangle. So I find the geometric mean between those two. Okay, so that is the altitude. So here's an example. So here is the short leg of the small triangle, and here is the long leg of the medium, right? So if I want to find the altitude y, I would take the geometric mean between 4 and 12. Okay, break down 4, 2 and 2, break down 12, 4 and 3, break down 2, 2 and 2, pair of 2s, so that's 2 times 2 is 4, and 3 is left over, so that stays inside the root. So y equals 4 root 3. So basically you can see you have this long explanation right here with all these words: short leg of the small triangle, short leg of the small triangle and long leg of the medium triangle. Take the geometric mean in between those. But as you can see, basically it's the two parts that make up the hypotenuse of the big one. So I'm taking the geometric mean between the two parts of the hypotenuse of the big triangle. So maybe that's a better way to understand it, okay, than all those words, right? It's the parts, find the geometric mean between the parts that make up the hypotenuse of the big triangle. Well, if we think about it that way, corollary 2 is actually not going to be that bad, I think. So corollary 2, there's actually two parts. So if I want to find, if I have the hypotenuse, okay, of the big one, that allows me to find the two other legs. Let's do a different color. Two other legs of the big triangle, okay? So, oops, probably shouldn't have done that. The red one here, that would be the hypotenuse of the small triangle. And maybe that's not a good way to think about it. Maybe the best way to think about it is just the short leg of the big triangle. Okay? So if I want to find that, corollary 2 says, well, you just take the geometric mean between the hypotenuse of the big one, hypotenuse of the big triangle, and the little piece of the small one. Okay, so the short leg of the small one. Okay, so that's how you find it. So you notice that I'm only dealing with the hypotenuse of the big one, right? So I'm taking the full hypotenuse of the big one and only the section of the section that I want of the smaller triangle. So if I want the smaller triangle, right, I want the little piece, then I'm going to take that leg that's connected to it. So that's why it says in here, like, the segment of the hypotenuse adjacent to the leg. All that wording basically means if I want to find this leg, then I need to take the piece that's connected to it from right here to right here. So maybe that will help in the understanding. So let's go ahead and try that on this example. So basically, if I want to find, let me erase all that. If I want to find x here, well, x is connected to this short little piece, 4. So if I want to find x, then I take the geometric mean between 4 and the whole hypotenuse, which is 4 plus 12. So break down 4 is 2 and 2, break down 16 is 4 and 4, pair of 4 is pair of 2s, x equals 8. Then say if I wanted to find, say, this one, let's say that z, well, corollary 2 works the same way, except for what's connected with z is this segment right here, 12. So if I want to find z, then I'd find the geometric mean between 12 and the whole hypotenuse, which is, again, 16. So I break down 16, we know, is 4 and 4. Here we got a pair. 12 is 4 and 3. 4 is 2 and 2. So pair of 2s, pair of 4s. So z is equal to pair of 2 is pair of 4, so 8 square root 3, which you can see is bigger, right? 8 and 8 square root 3. This one's bigger because this side is bigger than this side. Okay, so basically that is corollary 2. So you can set that up, right? So if you want to find x using corollary 2, then I'm going to use this section and the geometry between this section and the whole thing. Okay, what's nice about these, you don't have to rewrite it, right? If I wanted to find this one, z, say that's z, well, it's what's connected with z, this segment 5, and then the whole thing, right? So I find the geometric mean between those two. The altitude is a little bit easier, because if I want to find the altitude, then I just do both parts that create the hypotenuse. I take the geometric mean between those. So hopefully that's a lot easier for you to understand than all those words in there. It just basically deals with the hypotenuse of the big one. Okay, so there you go.